Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Good morning, everyone. Welcome to the second day of our Wpmc and Nrsem conferences. Second day, room 1, session 1. I would like to welcome everyone before starting. Thank you for your attendance. Today in our first session, we're going to have a 6 presentation. I would like to start this by inviting our first presenter, Ms. Sadia Farah, that will be presenting the paper titled Assessment of Sustainable Development Goal 6, Progress in Somalia Using SDG 6 Policy Support System. Hello, Sadia.
Hello. Hello, everyone. My name is Sadia Isa Farah, and today I'm presenting.
Can you please share your screen? Yes, it's okay now. You can start. Yeah, thank you.
Hello, everyone. My name is Sadia Isa Farah, and today I'm going to present our work on assessment of Sustainable Development Goal 6, Progress in Somalia, using the SDG BSS tool. This research was conducted in collaboration with Aslihan Karaja. In this presentation, I will cover these outlines one by one, starting with the introduction. As we all know, the SDG 6 is an important component of the United Nations 2030 Agenda for Sustainability Development. The SDG 6 is dedicated to ensuring availability and sustainability and sustainable management of water and sanitation for all. In the global context, water and sanitation are not only fundamental to human well-being, but are also linked with several other sustainable development goals. So, building on the importance of the SDG 6 in the global context, we recognize that undeveloped and developing countries face difficulties in achieving the SDGs. Our study narrows its focus to Somalia, serving as a case example to address the specific challenges faced reaching SDG 6. To systematically identify and understand these challenges, we utilize the SDG BSS tool, as the tool was designed to help countries facing limited data conditions and promote evidence-based policy to contribute the achievement of SDG 6. Also, the study will formulate the policy recommendations. If we take a look for the Somali is a country located in a Horn of Africa, bordered with the Indian Ocean, Ethiopia, Djibouti, and Kenya. And the key economic sector of the country depends on the agriculture, contributing significantly with 63%. Somalia is generally arid and semi-arid region The average temperature of the country remains between 30 to 40 degrees Celsius, and the average annual rainfall is about 200 to 300 milliliter. If we take a look for the water resource, the country has a total renewable water resource of 14.7 million cubics per meter per year. On a per capita basis, this translated to 924.9 cubic meters per person. By the way, this figures was data required from a World Bank in the World Bank. Also, the total water draws accounted 3.3 million cubic meter, with agriculture withdrawals account in 3.28 million cubic meters. If we take a look for the challenges that the country have for water management, the most challenges that the country experiences are droughts and climate change, which contribute to water scarcity. There is also a lack of infrastructure and population growth. Also, according to data from SDG 6 UN Water SDG 6 data portal, and the percentage of the population that have at least basic surfaces, basic drinking surface for the country count is only 58% nationally. Also, 39% counts for the population that uses safely managed sanitation services, whereas only 25% of the national population has only 25% of basic hygiene services. In wastewater treatment and water quality indicators, there was no data reported currently. For water use efficiency, it was $0.2 meter cubic. There is 25% of water stress. The degree of IWRM implementation of the country was improved from 10.3 in 2017 to 22% in 2020. The transboundary water cooperation accounted for 0%, and there was a rebate change in the water-related ecosystems, counting 25%. The international cooperation was $3.2 million. To gain a deeper understanding of Somalia's progress toward achieving SDG 6, we used SDG 6 PSS tool, as it is a tool designed to help countries navigate limit data conditions and promote evidence-based policy to contribute achieving SDG 6. So what is SDG PSS? SDG PSS is a tool for policy support system. It is an online system where the countries can input data, information, and trends, and then the tool transfers this input into fit policy evidence. The tool was developed by the UN University Institute for Water, Environment, and Health. And the tool organizes 6 policy components, which are capacity building, finance, policy, gender, and also disaster risk reduction. And also there is a status component, which provides overall view of the current situation. And each component of the SDG PSS is made up of 4 elements, which are resources, questionnaire, data, and reporting. So to fill out the questionnaire in the tool, we gathered data from different sources, such as we obtained data directly from national authorities like the Ministry of Water and Ministry of Energy and Water Resource in Somalia. Also, we sourced data from various UN agencies like the SDG 6 BSS portal tool. And additionally, we connected a short review of the existing documentations. In the results part, if we look at the capacity assessment, the first pie chart indicates that the majority of the indicators showcase adequate mechanism for capacity building nationally, except for the SDG 6.3 indicator 6.31, which there is a poor process in the progress, and there was a lack of data from indicator 6.52. By the way, these colors indicate indicates the level of the progress in each indicator. So the green color status for there is a progress or adequate progress. The light green is there is in development progress, and the red one is for inadequate progress, well as the black one indicates that there is no data or unknown. If we move to the second pie chart, the figure highlights the impressive progress of the lead ministries in developing virtual capabilities of indicator 6.51, while the several indicators including 6.11, 6.21, and 6.32, there are still work in progress. And there was an urgent need for data collection and reporting procedure in the indicators 6.31, 6.52, and 6.61. This ensures a comprehensive approach to attain the SDG 6. If we move to the national policy, the first pie chart observes that a positive development in national policy and implementation plans for the most of the SDG 6 indicators, except the indicator 6.52 and 6.61, which there is in development progress. But the second chart reveals a mixed picture in terms of cooperation and information exchange with other countries for SDG 6 indicators. For indicators 6.11, 6.42, and 6.51, cooperation is development showcasing efforts to strengthen collaboration. However, 6.21 and 6.31, collaboration is currently inadequate, indicating a need for improvement, working with other nationals on this aspect. Also, we found that there is no data from 6.1 and 6.32. For the finance component, it is evident that the finance and exposure strategies are adequate for indicators 6.1 and 6.2 and also 6.5, but however there is an absent data for the remaining indicators, as it is shown on the first pie chart, which they indicate is a black color. For the gender mainstreaming, there was a positive efforts observed from indicators 6.1 and 6.2, indicating an adequate initiative to promote gender involvement in decision making. However, there was in a development showcasing ongoing work in critical areas. For this table displays the summary view of each indicators and the SDG BSS components using color-coded to identify the level of the progress. So the columns of the table indicates the indicators of SDG 6, and the rows indicates the component of SDG 6 PSS. As we see, the black color it indicates there is no evidence in the black color areas. For the regions of the red color, there is a progress in place. If we move to the conclusion, the key findings from our study highlights both achievements and areas that require focused attention. There was a significant achievement in clean water and sanitation access, improved water resource management and sanitation facilities. Persisting challenges was found in rural and conflict-affected areas. Continued effort is needed for universal access by 2030. Mixed progress were found in institutional capacities, and there was challenges in human resource, infrastructure, and technology persist. There was a positive outcomes in recognizing women's role in the country, and also there was a critical need for sustained financing. The policy was in progress, most of the indicators, and there was a gap in enforcement, monitoring, and evaluating persist, requiring regular reviews. That's all of my presentation, and thank you for your attention. Hello?
Hello?
Hello?
Yeah, I think it's my turn now.
Sorry, I just my connection. I'm back. Do you have any question for Sadia? Any questions for Sadia? Mina, are you with us? Mina, do you hear us? Can you please open your camera, microphone? Hello?
They want to contribute. His name is David.
Mina, do you hear us? Open your camera and microphone, please. Okay, then we will take Mr. Abdullah first, then we come back to you, Mina. Now I would like to invite our presenter, Mr. Abdullah Qasim, to present the paper titled Exploring the Dynamics of Lake Conary. Yes, Abdullah, the mic is yours.
Hello everyone, I'm Abdullah Yasin Qasim. Thanks for attending my presentation. Our subject is exploring the dynamics of Conary Lake Safranbolo, a study on undiscovered natural wonder, which performed with Professor Dr. Tulay Ekemen Keskin. In this presentation, we will go through these subjects one by one fastly because we are restricted to a time limit. We should mention that Safranbolu is located in the Black Sea region in northern Turkey. It was an important station on the main east-west trade route. Safranbolu is among the places on the UNESCO World Heritage Center list, and Conary Lake is one of the tourist attractions and attract the attention to the city and the country. We have mapped our chosen points for conducting our analysis and observations. Here we have a brief report about the geological formation in study area, which are Safranbolu Formation, Karbuk Formation, Orancik Formation, Yuruk Member, Ulus Formation, Sonduk Member, Ahmad Usta Member, Yılanlı Formation, Burnuk Formation, which is basically contain limestone, marl, conglomerate, sandstone, claystone, granite, marble. This is a topographic view of the study area. These figures are an example of the karst topography which observed in our study area. And for the karst topography, here's a conceptual example of the karst topography which shows how the water flow under the surface through cracks and sinkholes and continue its underground flow, then it could find its way out and form springs. Our study delves into Lake Conary, one of the natural wonders yet to be discovered in academic and touristic terms. So, we conduct a water chemistry analysis, isotope analysis, and geophysical measurement were carried out alongside field studies. One lake, 3 springs, 2 wells, and 1 river measurement point located in the study area were mapped. For our research significant, we have 2 important steps. The first step is about analysis, which examination the physical and chemical properties of the lake and analysis of the results. The second step is about sustainability. Predict the future change in the lake and find effective solution to ensure the sustainability of the lake. For the objective of the study, we have observations, laboratory, and field experiments will be carried out to provide sufficient information about the lake. After that, and according to the results of the analysis, the water will be evaluated in terms of drinking and irrigation water, and the origin of Conary Lake and recharging area and the underground circulation time will be determined. For our experimental program, we have these flow charts that show we have a laboratory analysis and field measurements. We will go through these measurements and analysis one by one in the next slides. This picture shows one of the springs which located in our study area. And here is the multi-parameter device measurement process. This device can give us an important parameters such as temperature, potential of hydrogen, oxidation reduction potential, total dissolved substance. And here is one of the wells which located in our study area. And this is the measurement point which located in Eflani River. And this is video of Conary Lake sampling process. This video shows the inflow recharging for the lake from the bottom of the lake, also collecting the samples for our analysis. Also, we measured the flow in the channels coming out of Conary Lake using Molina device. For our isotope analysis, we have oxygenating and deuterium isotopes. Deuterium isotopes is one of the hydrogen isotopes. Those isotopes are used in hydrological and hydrogeological studies, and they considered the most suitable tracer for hydrological research because they are not radioactive isotopes, therefore they will not decay over time. And those are the deuterium and oxygenated results according to Vienna Standard Mean Ocean Water. These results can be better understanding when it compared with the reference lines. For our reference lines, we have Ankara meteoric line, Yozgat meteoric line, Mediterranean Sea meteoric line. When we classify our waters depending on those references, we can identify that our water is from a meteoric origin. So it's basically derived from precipitation. The other isotope analysis is tritium analysis. Tritium is a radioactive isotope of hydrogen with a half-life is just over 12 years. Tritium can be expressed as tritium units. This unit is often used in hydrology to calculate the relative age of the water. According to the references, our water samples is either a modern water from 5 to 10 years or a mixture between submodern and recent recharge. Examining the tritium content and oxygenating exchange is important in terms to reflect the relationship between the recharge heights of the water and their residence time in the aquifer. It has been noticed that the first Conary well, which expressed as KK2, have the highest recharge area and long circulation time. Also, we have Flani River have the shortest underground circulation time, and the lowest recharge area goes to the second Conary well, which expressed as KK5. For the geophysical measurements, we have two measurements. The first one is vertical electrical drilling, which measures the electrical resistivity of the subsurface layer by applying an electric current and recording the potential difference between two electrodes. The second one is the spontaneous potential or self-potential, which is a geophysical method measures the natural electric potential difference in the subsurface. It can be used to detect various phenomena such as fluid flow, mineralization, geothermal activity, and contamination. As a result of vertical electrical drilling measurements, there are clay, sand, gravel, and conglomerate were observed at all measured points until the first 200 meters depth. Those points are shown in the figure, and in the other measurements, SP measurements, the underground water flow was observed in the SP area shown in the figure. And those are measure anion cation results, all expressed by milligram per liter. From our anion and cation results, we can get our Scholar diagram. It is a graphical method used to express the chemical composition of the water. It is on a semi-logarithmic scale. It used alongside Piper diagram to determine the hydrogeochemical properties of the water sample. Also, we have Piper diagram. Piper diagram is a method used to graphically illustrate the chemical composition of water samples. In this Piper diagram, the anion and cation are separately shown in triangular diagrams and together in rhombus diagram. For our results, almost all of our water samples have a similar chemical composition, and it's been located in a region that alkaline earth exceed alkalis. Also, the weak acids exceed strong acids, except those whose related to the two Conary wells have a different chemical composition. Now we will gonna evaluate our water resources in terms of irrigation water. Firstly, we have Wilcox diagram classification. So we use sodium percent value to measure the harmful effect of sodium. Except the two Conary wells, the water in the study area is located for irrigation in region of excellent to good. Those two Conary wells are located in good to permissible area for irrigation operation. The first Conary well, KK2, is located in a sensitive area close to permissible to doubtful region. Also, we have US Salinity Lab diagram classification. Another most commonly used criterion for determining sodium damage is the sodium adsorption rate. We know that most of the samples other than KK2 and KK5, which express the two Conary wells, are located in C2S1 region, indicating a low sodium risk, and C2 class water can be used for irrigation of all of the planet that are moderately resistant to salt without the need for salinity control if there is a moderate washing process. The samples KK2 and KK5 are located in the area with high salinity, and this situation requires the use of planets that have the ability to tolerate salinity as well as washing process to remove the salinity accumulated in the soil. Now we get into the evaluation in terms of drinking water. Different limits have been adopted in different countries for various substances that can be found in water. In our study, we have the Turkish regulation on water for human consumption and the World Health Organization drinking water standards taken into the consideration to evaluate the water in terms of drinking water. For trace elements results, we can notice that all of the water resource samples exceed the acceptable limits of drinking water standards. And here we will have a brief conclusion from our study. Among the general properties of water resources in the study area, the electrical conductivity range between 100 to 1422 microsiemens per centimeter, and the potential of hydrogen pH values range between 6.16 to 7.61. Also, due to the Piper diagram, the water are mostly in calcium bicarbonate phases, but the KK2 well water was in calcium sulfate phases, probably due to the oxidation of sulfur minerals at depth. And the oxygen 18, deuterium, and tritium isotopes result shows that the water are meteoric origin, and the waters of Conary Lake and its surrounding are mixture of semi-modern and current recharge. It was determined that the water exceeds the standards for boron, arsenic, cesium, mercury, and some also exceed the standards for aluminum, manganese, cadmium, and ammonium. It is thought that the source of these pollutions may be the possible presence of sulfur minerals deposits in the region. Conary Lake leaking surface flow recharging might be recharged by limestone aquifer of different origins with a karstic structure located in the north-northeast of the lake has been recharged by a pressurized aquifer. And here we come to the end. I want to thank you for listening, and I wish a good day for all of you.
Thank you very much, Mr. Abdullah. That was a good presentation. Any question for Mr. Abdullah? Okay. Since no questions, I would like to move to our next presenter, which is going to be Ms. Mina Far, which is going to be presenting the paper titled Assessing Uncertainty of Drought Risk in an Arid Climate in Iran. Thank you very much for attending, Mrs. Mina. Hope everything is okay now and no problems. Stage is yours. And welcome again. Can you please present your slides? Just
Okay.
click the present. Click present, then share screen.
Okay.
Then when you click share screen, you can select window. From window, you can select your PowerPoints. And can you please a little bit lower your camera so we can see you?
Can you see my desktop? Can you see my
No.
desktop?
Not yet. But please, before you present, can you please? Yes, wait a minute.
There's not problem. Can I start my presentation?
Yes, but a little bit lower your camera, please.
Okay.
When you present, we still cannot see your presentation. When you present, can you represent again? Just press present. After present, share screen. Okay, after share screen, you can select window, not the entire screen. Don't show share entire screen. Just select window. From window in the middle, you can see your PowerPoints. So select your PowerPoints.
I don't know anything. Is there a problem? You cannot see my desktop.
Wait, I will show you. Just 1 second. What we can see is not what we want to see. May I share my screen so I can show you how to show this?
I don't know what is the problem.
Just 1 minute. Bitulalan, can you show my screen? Okay.
Can you please write for
open your.
me? Please write for me. Send message for me.
Okay.
What's the problem?
The
My
problem is that
listening.
we cannot see your presentation. That's why. Click present. Down to screen, you can see present icon. When you click present, then share screen. Share screen again. When you share screen, there is one window appear. Select window in the middle.
Okay, entire screen. Is it true?
açık mı şu an? No, it's not.
It's not true.
Yes. 1 minute. I will show you in WhatsApp. I will show you how to open your presentation. Okay. I will send you a video now. Shows you how to.
Can you see my presentation now? This is my PowerPoint file.
Tamam. Yes. Yes, that's it. Thank you.
Okay. Can I see? Can I start my presentation?
Yes, of course you can. Go ahead. Just about your camera, one last small thing. Your camera, if you can bring camera a little bit down, so we can. No, your camera, not the presentation. Yes, just move your device a little bit down, like this.
I don't know. Please type for me.
Okay. It's okay, no problem. Just open your presentation and go ahead. Keep the camera like this. Open your presentation and go ahead.
Okay.
Put it in read.
Can I speak?
Yes, of course. Go ahead.
Okay. Hello everyone, and and welcome to my presentation. Let me start my presentation on our recent study on the assessing uncertainty of drought risk in an arid climate in Iran. We know, as we know, the modeling and monitoring the meteorological drought and its uncertainty associated with it is a crucial aspect in the drought risk management. In this study, we use a standardized precipitation index or SPI to monitor this type of the drought. We know scales. This SPI can be calculated on different duration of accumulated rainfall, and any scales have a different meaning in the water resource management. In this study, we use artificial neural network or ANN models to model SPI on its different scales, and then we use the lower upper bound estimation or LUB method to qualify our model's uncertainties and through the estimating prediction intervals. Also to qualify our models accuracy, we use the wavelet technique to denoise the input vector. This study aiming to model SPI at Urmia climate station due to its high likelihood of drought risk. Our data included of precipitation on the monthly scale, also some time lag of precipitation and SPI to monitor meteorological drought in different time periods. We calculate SPI on the different time scales, i.e. 9, 12, 24, and 48 months. In this way, we use drought index package deep, and you can see the output of this software on the screen. What is the LUB for estimating uncertainty? This method uses ANN model to create a direct prediction interval with two outputs at once. The ANN is trained with a cost function called CWC, which balances two objectives, maximizing PI coverage probability, PICP, and minimizing prediction intervals, normalized average widths, PINW. Due to the complexity of CWC, meta-heuristic algorithms are needed to solve the optimization problem. You can see some mass formula of prediction intervals on the screen. Also, wavelet denoising method was employed here to remove high-frequency noise component from the input time series, which involves 3 steps of wavelet transform of input time series and thresholding the wavelet coefficient, which can be used through the soft thresholding rule, and then inverse wavelet transform for reconstruction the input time series. From the results, SPI model on the 24 scale obtained the narrowest prediction intervals and the low uncertainties at Urmia station. The closest uncertainty values to the SPI observation data is the greatest at this scale from the other scales. Also, from the lowest CV suggests the low dispersion of the data in this scale, so we can recommend SPI on the 24 scale for regional drought monitoring at the Urmia station. The use of denoise input vector resulted in the uncertainty reduction in all our use models, which from the CWC's and PINAW's perspective, which the highest reduction of the highest and the lowest reduction of the uncertainties obtained for the SPI models on the 9 and 24 months periods respectively. From perspective of mathematics, which we can conclude that the variance of the stochastic term in the SPI models on 24 scale is not very high. And then our conclusion in this study can make an initial guess about the risk of the drought and at the Urmia station. As we know, as the time scale of SPI increases, the likelihood of the meteorological drought spreading through the hydrological cycle also increases. And also we know 24 months period is considered as long-term scale for SPI. The climate at Urmia station is also considered as hot and arid. So we can say that we can conclude that the risk of drought propagation through the hydrological cycle can be significant for Urmia station. Thank you for listening. My presentation is over.
Thank you very much for your presentation. Nice presentation. Any questions for Mina? Any questions for Mina?
Thank you.
Okay, since no questions, thank you very much, Mina. Thank you very much. I believe we have no more presentation for this session. Thank you very much, everyone, for your attendance, for your presentations. Thank you very much. Now I would like to end this session. See you in the next session after 15 minutes. Thank you.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.